This is Digital Electronics Lab, and today experiment name is relation of JK flip-flop using logic gates. So there are four stages, that is J, K, Qn, that is present state, and Qn plus 1. We consider for 0 0 case, if the present state is 0, next state will be 0. If the present state is 1, next state is 1. So we can tell that there are no change. Next, for 0 1, if the present state is 0, that will be 0, and if the present state is 1, that also next state will be 0. So for this case we can say reset. Next, for 1 0, if the present state is 0, that will be 1, and if the present state is 1, that remains same. So we can say it set. For 1 1, if the present state is 0, that will be 1. If the present state is 1, that will be 0. So for this case we can say toggle. So from this truth table, if we summarize, we get the truth table, that is input and output. For input it is J and K, and for output it is Q and K. So we can see for 0 0 case, it is no change. For 0 1 case, it is reset. For 1 0, it is set, and for 1 1, it is toggle. So it is the truth table for JK flip-flop. Now we draw the circuit diagram. It is an input, that is J. There is another input, it is K. Output of the first NAND going to the another NAND. It will be same. It is Q and it is Q bar. Second input, that is clock, connected to both the gate. So this is the circuit diagram of JK flip-flop. we can see there are two types of gate we are used. That is, it is 3 input NAND gate and it is 2 input NAND gate. Now we discuss about clock. For the for the flip flop, we use actually two types of triggering. That is edge triggering and level triggering. We use here edge triggering. Edge triggering are two types: positive edge trigger and negative edge trigger. What is positive edge trigger? For the clock pulse, if we consider it is high, it is low. From low to high, it is considered positive edge trigger, and for high to low, it is called negative edge trigger. So for this circuit, we use positive edge trigger. Next, we have to give the pin number to the gates. As we see that there are two types of NAND gate. So first we discuss about 3 input NAND. You can see 1, 2, 3 input NAND. If we draw the pin diagram, internal pin diagram, the IC number is 7410 is the IC number. So 1, 2 and 13 inputs and 12 output for a gate. Next gate, this 3, 4, 5 are the inputs and 6 is the output. Next gate, it is 11, 10, 9 inputs and 8 output. 7 for ground and 14 for VCC. VCC is plus 5 volt. So we have to give the pin number from the pin diagram of 7410 IC. Now you can consider 1, 2, 13 input and 12 output, and next 3, 4, 5 inputs and 6 output. Next we go to the another gate. It is 2 input NAND. If you draw the pin diagram, you can see the IC number is 7410. It is called quad 2 input NAND. So first 1, 2 are the inputs, 1, 2 are the inputs and 3 is the output. Next 4, 5 are the inputs and 6 is the output. 7 for ground, 14 for VCC, 13 and 12 are the inputs, 11 is output, 10, 9 are the inputs, 8 output. So from this you can see there are 4 gates in an IC, we can choose any gate. So 1, 2, 3. We take 1, 2, 3. Next 4, 5, 6. So finally, we get the circuit diagram with the pin number of gates. So now we see the output in the analog and digital Tenor kit. Now you can see the kit. It is the plus 5 volt and it is for ground. There are two IC. This is 7410, that is 3 input NAND, and this is 7400, that is 2 input NAND. Now we design the circuit as per the circuit diagram. So first we have to give the plus 5 volt to each IC. We give plus 5 volt to IC, that is pin number 14. We have to short both pin number 14. Next, go to the ground connection. We know the ground is pin number 7, so it is given to pin number 7. Then both IC are shorted. Pin number 7 and pin number 7 are short. Next, we go for the first input, that is J, to the pin number 2 of the 3 input NAND, this one. Next, pin number 13 and pin number 3 of the first IC is shorted. So pin number 13 and pin number 3, this one, shorted. Next, pin number 1 of first IC, this one, and pin number 6 of second IC, shorted. Next, pin number 4 for another input, that is K, is going to pin number 4 of first IC. Next, pin number 5 of first IC, that is 7410, and pin number 3 of the second IC is being shorted. I request all of you to make the circuit diagram first and then see the practical part. Next, pin number 12 of first IC and pin number 1 of second IC is being shorted. Next, pin number 6 of first IC and pin number 5 of second IC shorted. Next, pin number 3 and 4 of first IC and 4 of first IC shorted. Next, pin number 2 and 6 of second IC, pin number 2 and 6 of second IC is been shorted. There is another connection, that is clock. You can give clock. You give the clock, that is 1 Hz from the kit. To the 13 or pin number 3 or 13 of the first IC. I give the connection to pin number 13. So internal connection and the inputs are connected. Next we go to the output. So it is Q. It is connected to pin number 3 of first IC. Another output, that is Q bar. It is connected to pin number 6 of second IC. So now you check that the pin number 3 from the second IC, there are 3 connections, and from the pin number 6 of second IC, there are also 3 connections. Now you can see the circuit diagram. This is the circuit diagram. Now we check as per truth table. So first we switch on the kit. For 0 condition, it is shown firstly, and that is Q bar is glowing. So we give the J is high. You can see the Q is high. Now if we give 0, there will be no change. For 0 condition, there is no change, that is Q is high. Now we go for 1. You can see for 1, the Q bar is glowing. If we give 0 condition, there will be no change. So it is satisfied the truth table. Last one, we go for 1. If we go for 1, first of all, we give the 1 to the Q bar. If we give the 1 to the J, and of the K, that is 0, and J is high, that is 1, and K is 0. Now if we if we give 1, it is seen, this is called toggling. That means the memory cannot set the story. So it satisfied the truth table. Thank you.